WWDC. Thanks to God that I am able to share and you are able to listen today. Today's my topic is concurrency in Swift. So I have lots of topics to cover, but we will understand first, and it should be useful, and in less time you should get so many things, and it should be easy in adoption. So whatever pain point I faced, I'm sure I'll not uh, give you that same path, and we can just make it more simpler, more easier. So quickly I'll go and just cover some topics, and you'll be able to inject async await into your projects. Now, first of all, what is concurrency in Swift? Some questions I have created for myself. So what is concurrency in Swift? So basically, first of all, I observe it through the dispatch queue, operation queue, and then finally your async await came in the picture. So what's happening here? All things are playing with old. So old things are not going anywhere. Like it is on top of the thread. That is pretty clear. Now dispatch queue, we just work over there on the dispatch queue. It is low level thing where we can just execute our functions with the low level global key, queues. Queues can be your number one can be global, number two can be your custom, and number three can be your main queue. That's all three things will just use QoS. QoS in the sense quality of services, which can be perform your task, like if you are just playing some audio or watching TV, watching video, or something you are just downloading from the system parallelly, then those tasks should have some priorities, and those priorities we can set up through the QoS. So the QoS is like user interactive, or you can say background, or you can say high or low, and those are not going anywhere else. So those are there in all three cases. Now this is over, the game is over for this dispatch queue, and the operation queue on the top of this, like we were calling some loops and we are calling this dispatch queue, and we are not able to handle them strongly. So on the top of this we generated, like Apple generated operation and operation queues. So these queues are dispatch queues, mainly three types, and this is the operation queue where the operation and operation queue will adopt the block operations. So the block operations will go on the operation queue as an array, and then you can perform them very easily. And once you will just cancel something, you'll be able to cancel on cancel function. You can run them, start them, and control them easily, rather than it was little typical in dispatch queue. That's all. But yeah, it was introduced in Objective C time. It is introduced into Swift time, from 14 September 14, and now it is here like async await. Why? Because we are playing with closures, and you know the closures are giving you the trouble over there on the memory management side. So every like 100 view controllers, you are just calling lots of APIs or lots of other tasks like PEL asynchronous tasks, then they should be into the weak self reference or unwound self reference, and these kind of management issues we have to handle, and those things are giving us trouble, and we have to scratch our mind. And also nested loops due to higher order functions means like function inside function. So the closer it will go like some, you are just call simple example, you are calling one API, then you are calling one inner function itself, and then inner function can get more inner functions, and this will be very nested thing which will come through the curly braces, and the code will be pretty meshy and like not able to handle this strongly, or if somebody will read it, it will be pretty hard. Fourth thing is like this is not a structured way, and we can focus over there on structured way, and like async await will help us. And one more thing is there, like async and await operations, and this concurrency, new concurrency is taking care at the compile time suggestion by error, rather than going on runtime. And once we are just creating any dispatch queue and we are not able to, or operation, we are not able to handle them at runtime, and we are not able to understand like which what is the data race, and which variable can give you the interrupt, and something can be failure over there into the loop, or these kind of things can happen at runtime. So this compile time error, firing the error in concurrency code is very good for developers, for us. And like we can just find the error at this time only through actor. We can just use this, and through this async await itself we can just take the leverage of this compile time, understanding and grabbing errors. While going further, it should not give you the mistake. So you can understand lots of points here why we should go with the async await, and it is pretty simple in less time. Now what we will do, this is over, we understood this. Now we have to understand what exactly this one is, like how we can implement this concurrency. And concurrency, the newly created concurrency, what what they try to explain us. So now if you will understand, like there can be the concurrency is a on the top of thread, as I said. So so concurrency is on the top of thread. So this is basically on the top of threads. So threads means those can go with the asynchronously, and one can go with parallelly. Now what is that? So asynchronously means you have some T1, T2 and T3 tasks. So now how you will perform them asynchronously means your one task will be here, another task will be here, and another task will be here. So in between them, micro milliseconds gap will be there, and you'll be able to listen your audio, or you'll watch the movie, and your background data downloading will be there in simple style, and you'll think like it is going parallelly. But yeah, no, they are going on the same core processor, and things are working over there in micro milliseconds, and they are sharing the data. So you can understand this sharing the data is very important topic, and because of this they introduce sendable thing. And sendable protocol is pretty powerful, that I'll explain you later, and it is very nice and very simple. So by that way, like we just make sure like whatever we are sharing, that should be good enough to go with this concurrency race. Now what is parallel actually? So the parallel is like it will go with the same thing, like if you will understand, because things should be easier. So this will go parallelly, and in the parallel those tasks will run without any time gap. So they require three core processor, C1, C2, C3 in parallel. So if three slots are there, they will go on three slots on the same time, and this will be your parallel thing. Now how we can just execute this thing? We will we will just doing this thing into the dispatch queue like dot sync and dot async. We are making queues over there, and those were dot sync means your synchronization will hold some process, and after then only the rest of code will work. So it is saying I am superior, I will take 5 seconds, but I'll not give you the permission that without full execution of mine you should go away. And this asynchronous is saying like I'm going for 5 seconds for somewhere. You can enjoy your work and you can play continuously. Once I'll come back, I'll join you. Something like this. So this is the pretty simple thing which is covering almost all things. Like it is good enough for future interviews as well. And now what we can say, like how I need to be familiar with async await. Actually, how I will perform these two things in asynchronous. Now I need to perform, right? So I have one warm up playground, and in that we will understand async parallel. We understood. Understanding of structural concurrency means it's nothing like structural concurrency means we are get it out from closures, and this will go with a structure way, and it will be bound with one inside another, and things will be very easy and connected. Now we need to understand this so that we can write something quickly. So I created one warm-up playground here. This playground will give us a good feeling, and like it we will be able to compare whatever the old thing were there. So we should respect that. Now one message is there like greet, and this greet message have some message, and this message you can say it was a closer. So if you will see this, this is a closer, and it will give you a result into the string, and it will return that thing. Now this message should be something like that. Uh, Message can be your string, and this can be your greet. Now this greetings function will give you a greet message. So now I need to greet. I'll use greet message. I'll say message, and you saw like it can come quickly here message. So this is a closer. You need to use weak self here. You need to use unwound and those things there, nested loops. It's a high order function because it's calling inner function. So in FRP, functional reactive programming, it will be longer, but yeah, like again we are manually creating those closures, so if somebody will read our code it will be pretty hectic if functions inside functions will be there. Even though if we'll see our code itself it will be hard, but not the single reason. Like async await on the top, they are informing us like what is the concurrent way and how we can go with the compile time error, like if we are doing mistake into database and all these things, right? So I can convert this into a call API function better, like we can use the result and we will understand like how it will work into error case handling also. So result is nothing but it is success and failure. In success case you will get a string, in failure case you will get some error. You'll convert this message into a response of result, and that result should be your success result, and you can say dot success can come something like this, and it can be a have a nice day, and then you can say failure will also be there, but I do not want to use right now due to this example set, and you will see this result will be there, and you need to use the try and catch block for this. So quickly I'll say switch result case dot success, and this is called API function. So now it will come success, let result message, and this message will be, I'm sorry, print, and then in the case of failure it will give you some error and you'll be able to handle that error also. So it's giving you a feeling of calling the API, the dummy API. Now the last thing is remaining there, like it's not giving us a time break. so it can call within a 5 second. We'll use our dispatch queue. Main means custom and global. We should not use this. So main, what you will do is you will just execute this thing over a time limit. So I think this is good. So time will be dot now plus 5 second will be there, and you can just call it nicely the same result there. So it will take 5 second delay, and make sure like it can be escaping at the end. Means this dispatch queue 5 second is going with another block. That means me myself means call API is saying, hey, you are escaping for 5 seconds, so keep inform me like you are going somewhere for 5 seconds. So that's why we are using this. Now if you will go and just see, after 5 seconds it will give you results. So after 5 seconds it gave me the result. Now all things are clear. The old existing things, whatever we just try to make, we are just trying here. Now what we need to do, we need to understand like how I will perform async await over the same situation. So how it will work. So basically we'll try to cover all these things again, but using async and await, so it can be adaptable and simple for you. So, and also we'll see like what is the asynchronous call and what is the parallel call. So for this, like first I need to tell you in simple way, and then we will just try to do the same thing with this example as well. So what you need to do is you can comment it and first try to understand like how we can write the async await. So to do the same thing with the async await, so how you need to do, first we will understand, I said like understanding on of structural concurrency means it will go in a structured manner. All the code will go inside the concurrency family, otherwise it will not execute, it will give you error in normal classes. So we have to use how you need to create this. So async and await function we'll understand first. So basically async is saying I'll go somewhere for 5 seconds or for 50 minutes or whatever. Await is saying like I will keep on inform you that whatever function is there, that is asynchronous function, and it can go somewhere. I am giving you the guarantee it can go somewhere and it will give you result after some time. So this is not normal function, it is the function which is going somewhere for some time for reason, and it will come with the result like with a success or failure. That's all. Now how to write async and await simple function. So means like how we can write them. We can write them in two styles, which is simple function and second is error handling function. So how we'll perform them, we'll understand that. So call API I created using failure and success both case. So you can say a simple function will be there which can be a message, greet or something like that. So this greetings message will be your simple async function where you will type async and you will focus on your success, which is your message, and you will say return, and return will give you have a nice day. That's all. And once it will give you this result, how you will call it actually. So you need to, async is saying I'll go somewhere for some time, right? So I need to go somewhere for some time. So there is a task actually, and sleep function inside this. This will saying a function like until, and this is saying like I have the now same like yours, and I have a seconds also, and in the second I can put 5 seconds, and clock means this can be your continuous or suspended, means you can see a clock that measures time that always increment but does not stop incrementing while the system asleep, or while the system asleep but it will stop. So once system will sleep it will stop, and something like that duration and instant, and those things are there. So those are different variables we can use. I'll use continuous, and this is basically a simple testing method for testing this message, something like async after this thing. And my target is to, and it is a throwable function. So it is a throwable function means it is a async throws function. So it will give you async throws result, async throws function. That's why it is saying I can throw something. So I'll say throw, and throw is there, then try will be there, right? So it can be try for some time. So if you are just focused on the simple thing, it is done. But now if you want to handle the error also, and inner things are giving you error, then what you can do, you can put one throws keyword in front of async and in between this arrow. So this is your second style of async function, how to write async await functions with error handling, right? So now it will handle all the things, whatever things are coming from there. You can use do catch, but traditional way, if you will go loop inside looper, you will get irritated, and like again nested things will come, and it is not good. So it will take care directly, and it will give you the error here in a traditional way, whatever we are thinking. Now it is saying expression is async here, so please use my friend await here. So await is always be attached with the asynchronous keyword, and it is saying I will be the await thing, which is informing that this sleep will go somewhere for some time, and then it will come back and it will give you the result. So this is the task. Now task is again big picture, we'll cover it later. It's a sendable thing, secure thing. So all the things going through the async, they are confirming the sendable protocol, means protection of data race. So that we will cover later. And for the confidence of adopting the async and await, I created this in a quick manner so that you can adopt this and quickly you can jump over there on your existing projects. So async, now it will give you result or not, we'll see. So basically if I'll call this greeting method, it is saying error, and it's saying used in context that does not support concurrency. You are using this thing into the simple playground, and this is not a part of your my concurrency family. So I said what I need to do. So I requested to the task, please come here and just add me in your things, and just give me a uh, result. And then I'll say this is also async throws, same like task sleep now, and what you need to do, try and await, and then you can say my greeting message. So once we'll do this, something will be there. So this came as a success. So task is performing, you saw, like this is a sendable protocol which is giving you success and failure, which I already told you. So nothing is there inside this task is basically success and failure result. But don't be confused about this task, we'll discuss later. Right now focus on this message itself. So what will happen if I'll not use this, basically it will run. If you will not use this, he will say like this is a async call and does not support concurrency. I'll say I'll just put my await thing here. It will say okay fine, I'll go further, and it will silently go further into playground, but it will not work into your real project. Why? Because it is not on the top of async, so error will be there. Error is execution is stopped with unexpected error. Execution was interrupted, and the process has been left, means it is left. It was not on the concurrency family. So that's why it is giving you this error. So I said like okay fine, you gave me the result but it interrupted, so it is pretty hard and pretty bad. So if you will see print message, so if you will playground execution will fail, because yes it's true, it's not on concurrency, and it is on the task, not on the task, and not on the structural concurrency system. And it is beautiful. Why? Because it is informing us. So you say you check this have a nice day message is coming here, but after then it's failing, means it's not secure enough. So in the project it will give you red error on the spot over there into your .swift file. So basically just say it should be into the concurrency family and it should be independent task. Now we'll discuss this later with sendable. So there is lots of discussions will happen, but don't worry. Right now we have to focus on this async and await learning itself. So you saw this came nicely and message also get printed, have a nice day. So this is perfectly fine, and we understood the async and throws things like the try catch, all the things. Now what you need to do is, this is a 5-second delay and this can be a example of your asynchronous call of 5-second delay, and which can be give you results something like that. So if I will make some surroundings here, like in the Apple doc it was there, like you can say I'm here, I'm starting, right? And you'll say I am finishing. So now you will say what you'll check what result will come. So it is saying I'm starting, I'm finishing, but after 5 seconds it will give you have a nice day. Now what I want is, I want the same thing after finishing, like I'm starting, I'm finishing, and have a nice day. I went there for 5 seconds after I am starting, and then I never stopped. I am finishing, and I went there for 5 seconds and I came back and joined the team. That's all. This is async call. So we are not disturbing, and parallel things are happening. Like asynchronous calls are happening. But what will happen if I want result in parallel, like sequence should be there, like my all photos will download it and then only I need to show them, or something like that. Some examples will be there, how I will handle them. So those points I written here, how to perform tasks asynchronously and how to perform tasks parallelly. So parallelly we need to understand how we can just call them. So what you can do is, like this await you will not use at the very first time, and this async what you are using with the functions, whenever whatever result success result will come, will focus and load that into a variable, and that variable will called as async, and this will convert into your parallel results. How? So this is your async, and now I just want to give you example of parallel things, like sequential things. So in the sequence you will be able to perform something. So this will be your sequential things. So how? So suppose the same function, quickly I just want to create here greetings, and this greetings I just want the same thing in parallel. So what I'll do, I'll say task, and in the task I will call this. So how I will just calling the message. The message can be anything, like whatever I'm just passing that can come to me, right? So this thing I can just say whatever I'm passing, this should give me the result. So now what you will do, in the task we know very well we have to use this, and this should be the parallel one. So I'll say let and message 1 or greet one, and you can say call me, but I want them in parallel. So call the greet message, and message will be your greet one. Will it work? We'll see. So it is working. right? Now I don't know how it will be there. So greet 2, now this is 2, and keep on adding, and this is the greet 3, greet 3. Now what you need to do is, can you call this print I'm initiating and I'm finishing here itself into this task, or whether it will give me error, we'll see. So now this task will get performed with 3 different executions after 5 seconds. So we have to delay less, like 2 seconds, and you can say run it please, because this is a sequential call. So I'm starting and I'm finishing, right? So this is calling something like this, and these are the operations, those went well, and they are not able to taken care by us actually. So what we can do is, we can say let complete result, I think, right? And we can say await, and we can perform them. And how? Like total, and you can say greet 1, greet 2, and greet 3, something like that we can try, right? So this is 3. Now we'll try. So it is saying it is throwing also. Okay, please throw something. Now we'll see. I am starting, it stopped here. I am finishing, it stopped here. And complete result is also there. Before also it was there. Actually, I'm sorry. We will print them. We'll print them, and you will see. So total is greet 1, greet 2, and greet 3, and it is taking 2 second time, and then only I am finishing is getting called, right? So second can be increased like 5 seconds, and then again I'll run this, and we have to check. Yeah, it take time. It is taking time, right? So after 10 second, it is saying greet 1, 2, 3, but I am finishing is little later. So this is your series thing, right? So you understood this thing. One, then gap of some seconds, but it is not giving you the finishing. And after finishing all 3 things, above things, it will give you the complete result, and then finally it will call the later stage. So this is a synchronized way to deal with task, like whatever in the concurrency, and you can just use this thing nicely, right? So again, if I will increase the 15 second, you will be able to see, like after some time delay or little more delay, it will come, but yes, it will never call this finishing at the very first time, right? Like first finish all 3, give me the result, and then come back here on finishing. So hope you enjoyed well, and like you got the exact scenario, what is the asynchronous and parallel thing, async await call, and these things. In next topic, now it is pretty easy that how we can just inject this into our existing projects and into the fresh projects using API call example or etc, that we will see in the next lecture. Thank you so much for watching this.